Alright, so this video is part one for going over the Unit 1 review packet for the quiz tomorrow. The first ones I'm just going to just speak into it as opposed to writing down on there. I'll post the answer key on the website as well. What is a physical change, and give two examples? Well, physical change is any change that does not alter the arrangement of the atoms within a molecule. So for instance, if I take an ice cube and I melt it, it's still made of H2O, but whether it's solid or liquid. So that's a physical change. Another one is if I rip something in half. If I take a paper and I rip it in half, that would also be a physical change. It's still made of paper when I'm done. As far as the three phases of matter, and describe the shape and volume of each. We got solids, liquids, and gases. Gases, I guess, are the most diffuse. They take the shape and volume of their container, whereas a liquid takes the shape of their container, but the molecules are much closer together, so they don't take the volume of their container. They're more condensed. And lastly, solids, they're rigid. Their shape is fixed as well as their volume. So that's number two there. What are an element, a compound, and two types of mixtures? And give one example of each. So an element is any substance that's made entirely of one type of atom. So imagine if I have a ring that's made entirely of gold. That's considered an element. Another example would be aluminum in an aluminum can. The oxygen that we're breathing, although that's technically a compound because it's two molecules, two atoms of oxygen. So a compound is a combination of two or more different types of atoms chemically combined. So water would be an example. We've got two hydrogens for every oxygen, whether it's a solid, liquid, or gas. Sugar, as we learned last year in biology, or a couple years ago in biology, we got glucose, which is byproduct of photosynthesis at C6H12O6. C6H12O6, yep. And then two types of mixtures. You've got homogeneous mixtures and you've got heterogeneous mixtures. A homogeneous mixture would be something that's the same throughout. So if you sample different areas of that mixture, you'd come up with the exact same components in that sample. So for instance, salt water. If I mix some salt and water, stir it up really well, dissolve all the salt, the water is just as salty everywhere throughout. Another example would be like Kool-Aid mix. So I mix together Kool-Aid. There's no part of that mixture that's any more Kool-Aid-y than any other part. And then a heterogeneous mixture would be a mixture that has different components throughout. So big example for this one I like is trail mix. So trail mix, you might have some raisins, some peanuts, some M&Ms, granola, those sorts of things. If I took a handful from one part of a barrel of it and I compared it to a handful from another part, there's probably going to be the same stuff in there, but not necessarily the same quantities of each thing, so it wouldn't be as uniform. Another name for a homogeneous mixture would be a solution. And lastly, if we take a look at number 4, difference between an intensive and an extensive property. Give one example. Well, an intensive property would be something that's it's the same whether we have a little bit of that substance or we have a whole lot of that substance. So for instance, density would be an intensive property. If I have a gold bar and I cut it in half, each half is going to have the same density as the original bar. Another would be like color. So if I rip that gold bar in half, same color, doesn't change color. Whereas an extensive property depends on how much of that substance I have. So for instance, back to the gold bar, if I have less of it, its mass is going to be less. So mass would be an example of an extensive property. Length, volume, those sorts of things would be extensive properties. If I change the amount of it, these properties that are extensive would change as well. Difference between a theory and a law, this is a big one. A theory kind of proposes an explanation as to why something is occurring in nature. So for instance, with evolution, why do populations change over time? Basically you've got variation within the population and different selection pressures select some that are better able to survive, and therefore over time you're going to get differences between individuals in that population. Whereas a law just explains what is. It doesn't really try to go into why something is occurring. So like the law of gravity, if I drop something, it's going to fall. It doesn't go into why it falls. It doesn't explain why things have gravity. And then lastly, for part 1, what is a chemical change? Basically, it's any change that causes the rearrangement of the molecules. So if I were to burn something, the fuel is going to be different than smoke and soot and whatnot that comes out.